Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy. Academy is for you to take the right decision, to move in the right direction, and to reach at the right destination. In today's lecture, we are going to learn how to design strut-based cylindrical periodic lattices. Okay, so here, we are considering some strut-based unit cells, and thereafter we are incorporating these unit cell within the cylindrical cell maps and then trying to design the periodic lattice structures. So let's start. Before that, can give the file name as strut based cylindrical periodic lattice structures. Then we can add the description as the design of strut based cylindrical periodic lattice structures using strut based unit cells. Okay, now we can give our section name as strut based cylindrical periodic lattices. Now, to generate the periodic lattice structures, we first require the periodic lattice. So in nTopology, we can get it from lattices tab, and thereafter within the lattice tab, we can find the periodic lattice. Okay, so either we can select it from here directly, or we can also search that block using here like a periodic lattice. Okay, so like this one can get it from either here or from here. Now let's delete one of them. Now what do we observe here? We need to define three geometrical parameters. One is unit cell, the type of unit cell we are going to use, and second one is the cell map. Cell map means in which shape, either are we going to create a like a rectangular, like this, like coordinate Cartesian coordinate system, or cylindrical coordinate system, or spherical coordinate system based lattice structures. So in topology, we have three types of cell maps, and one is rectangular, and second is cylindrical, and third one is spherical. Okay, so I will show you from where we can get it. And the third parameter is unit cell parameter one. So it is majorly depends on unit cell. Okay, so I hope you understood till now. Now how can we get unit cell? So let's double click here. What do we observe? We observe that there are various type of unit cell. As I said, in today's lecture we are generating strut based unit cells. Okay, so is there any name do we find here? No, right? So how can we get it? In nTopology, the graph unit cell, also known as strut unit cell. So let's select this. Okay, either we can directly select it from here, or we can get it from this unit cell tab within the lattices tab. We can get it from here as well. So total different type of unit cell we have. As I said, we are going to use graph unit cell. So let's select this. So as I said, now we have graph unit cell here, and we already fill here. We can take it out. Okay, so now it is empty. So we have two graph unit cell, and one more method is we can directly search it from here as well, graph, or you can simply type unit cell. So from here as well we can get it. So in three ways we can get the different type of graph unit cell tab. Okay, let's select only one. So here again we need to define two type of geometrical parameters. One is the type of unit cell we are going to use, and the orientation of respective unit cell. So as we are using cubic unit cell, so the orientation doesn't have that much effect. Here we have different type of orientation. They have major impact on 2D type of structures or any asymmetric structures. So okay, so let's select the unit cell type. Here we have different type of graph unit cells, so we can choose any one of them. So let's select simple cubic graph unit cell. This is our simple cubic unit cell, as we know in our early stage of mechanical engineering subject. So this is our simple cubic. What do we observe here? There is a blue color box, so it is known as bounding box. And we also observe that u, v, w, like axis name, so that is a local coordinate system. And we can turn off them using display settings. Just click here, and from here we can uncheck them. So now we are not able to see. Okay, So this is our unit cell. Now let's place this graph unit cell within the unit cell tab, and let's minimize it. Yeah, our second parameter is cell map. So which cell map do we want to use? It is obvious that in today's lecture we are going to focus on cylindrical coordinate system, isn't it? So let's select the cylindrical cell map. How can we get it? Either double click here. So do we have any cylindrical cell map? Yes, we have cylindrical cell map. Other than this, we do also have other cell map. So let's select cylindrical cell map directly from here, or we can go to the lattices tab, and thereafter we can go to the here cell maps, and here we have various total 6 types of cell maps. So let's select the cylindrical cell map, and as I said, we can also get it from add block like a cell map. From here also we can get it. So let's select only one. Again, what do we observe here? To define the cylindrical cell map, we must define various geometrical parameters. What are they? One is volume geometrical parameter. We need to define the volume of the cylinder. What is the volume? What are the parameters do we have? One is a cylinder height, and second is a radius of. Okay. Similarly, cell radius. The cell radius indicates the as we are going to generate a periodic lattice. So within the lattice, we need to define the unit cell, isn't it? So for that unit cell, how much size we should maintain within the cylindrical cell map. So that we need to give, and then cell height, the height of the particular unit cell within the cylindrical periodic lattice, and arc count, as we have the cylindrical shape, so it has different type of arc. It is up to us how much we need to give, but minimum one we must give. And then linear, generally in cylinder, as we have the cylinder, it we always have the curvature type of ligament. I will show you what exactly means. And then a frame, it is up to you. If somebody wants to create the new frame and generate the respective cylindrical map from with respect to that frame, then one can freely design it. So let's define one by one. And yeah, here our volume. So we can get the volume directly from here, but I hope uh, we cannot get it from here now for this purpose. So let's select it from here, or we can go here, like a create tab, and then go to the primitive tab, and then here we have various type of volume shapes such as a cube, cylinder, and sphere, and torus, and cone. So let's select the cylindrical cell map. Again, just minimize our unit cell. This is our cylindrical cylinder with a, it has a initial point at the center of the bottom face, and it has another point where its height is up to maximum 10 mm. Okay, like that one can tune its this parameter as well. So if somebody wants 20 mm, then they can freely change it. So let's go with that only as it is. And the radius, the second parameter is radius. If somebody wants 10 radius, then this is the one can give. So let's go with 5 radius, and let's place this block within the volume block. Now we have defined the first parameter within the cylindrical cell map, that is volume. Now we need to define the cell radius. As we have the cell radius as a 5 mm, let's give the cell radius as a 1 mm, 1 mm of the unit cell. And let's minimize our cylinder. And next, cell height. Cell height, as we have the cell height as up to 10 mm, then we can give it as a 2 mm. And number of arc count, we can give either 1 or 2, minimum we have to give, but let's give the 3 arc count. And now let's see. Yeah, this is how this is our cylindrical cell map. And as I said, it used to maintain the cylindrical coordinate system, and it has a radius, and total number of arc we have, arc counts are 3, first arc and second arc and third arc, and respective radius. This is a, within this, this is our radius, and within each of them our unit cell is going to place. And again height, similarly different layers we have, and our unit cell is going to place it there. Okay, now let's make it a, let's, yeah, now we have defined this. As I said, linear. Now let's see what is mean by linear. Yeah, earlier we have curved links, right? Now if once we check the linear one, then we have the straight links, isn't it? So, although it is maintaining the cylindrical shape, but the links are like a straight shape. Okay, so that's why let's uncheck it. Now this is our cylindrical cell map. So we have defined this. Let's place the cylindrical cell map within cell map. And now the last parameter, that is thickness. Earlier it was unit cell parameter one. As I said, it majorly depends on the unit cell type, isn't it? So as we use the strut based unit cell, so there we have the only one geometrical parameter, that is thickness. So we can use this as a point. It's up to you, 3. Let's 0.3 mm we can give, and let's see what is going to happen. Yeah, finally we have generated the simple cubic based cylindrical periodic lattice. How beautiful it is, isn't it? It has different layers of height, and different arc counts. If somebody wants to tune the thickness and get the desired relative density or porosity, they can simply tune this parameter. So in today's lecture, we are going to discuss regarding the 2 or 3. So see, now its relative density is increased. Now if somebody wants to change the other unit cell, so that is the advantage of this nTopology software, as we have different unit cell here. So let's see how body centered cubic is going to uh, show within the cylindrical cell map. It is generating. See how beautiful it is. So within the cylindrical cell map, our body centered cubics generally see within this it has total 4 diagonals now. So it covers or it occupied within the given. Suppose if we change the cell arc count as a 5, then let's see what is going to and how it is going to look. Okay, let's see total how many arc count do we have. See how beautiful it is, isn't it? Total we have total 5 arc count, 1 2 3 4 5, and it has height and radius as well. So this is how one can design the like various type of strut based cylindrical periodic lattices. I hope you guys understood till now what we have done. So in today's lecture we have designed like stud-based cylindrical periodic lattices. For that, we have selected the periodic lattice within the lattice tab, and then thereafter we have defined each individual geometrical parameter such as unit cell from here, graph unit cell, and thereafter we define the cylindrical cell map using cylindrical volume and different parameters, and we also defined the thickness. So I hope you understand. Uh, I'm going to give one more task, so you can practice it. So you can design for other type of unit cell and observe them how they are exactly looks like, and that task is for you, and practice it and learn it in depth. I hope you can enjoy the lecture, and you can also tune other parameter as well, like cell radius, cell height, and so I what I can say that you can practice this and play with the parameters and generate different type of lattice structure and just play with them. Okay, that's it for today.